This video is going to go through the answers and work for the algebra refresher. Also included links if you need a slower, more detailed version. I'm going to go fast, so you might want to pause, rewind as you watch this if you're going to use this. First problem, describe the pattern. We've been doing that. Just look for what's happening. It's like dividing by 2 each time. Second one, simplify, distribute 12n minus 28. Always draw the lines. That's a negative 2, so that's 10n and then minus 16. Again, draw the lines, make sure you don't mess this up. We've been doing a lot of one variable equation. This should be okay. 22n, and then combine your like terms, minus 44. Don't mess that up with adding when you have a calculator available. Okay, one you may have forgotten is an inequality here. So this is a compound inequality. Whatever you do to one, you do to all three. It's an inequality. A single inequality would be like an equation. This is just kind of like the same thing. You balance it out. So I know I want to get to n by itself, so I'm going to subtract 3, but I have to do it for all of the spaces. So this is negative 9, less than or equal to n, less than 12. What do you remember? We need to go to our graph, and this may be a digital thing on the ISTEP. With the open and closed circles, you just got to drag the right little dots there. So I know I just need a point at negative 9 and 12. I'm not worrying about everything else. And if there's a little line underneath it, it means equal to. That's a solid. And if there's not a little line, it means less than. So I want everything less than 12. So the arrow's going this way. I draw my arrow coming back this way. And I want everything where n is greater than or equal to negative 9. So we're talking about stuff in between these two. So on the ISTEP machine, you're going to have to drag the right little dot there to get those values. Okay, this is a straight substitution problem. Evaluate means plug in. Again, it's something that we do in geometry. We don't do with squares. One thing I'll give you a use caution here. Take this step. You wouldn't want to miss one like this just for being sloppy. So do this step right here. If you put this in the TI-84 calculator that's on the test, it will work. If you put this in the calculator that we let you guys use, it will work, but you might not all have access to that all the time. It only will work if you put the negative 4 in parentheses. If you don't put the negative 4 in parentheses, then you're going to end up with a value being squared and getting negative 16 when you should get positive 16. In general, on fancy calculators, this little button, this caret button, is what gives you the exponent. So I have 3 to the third, oops, 3 to the third. And push the arrow back down. So it's worth checking to make sure you put everything in right, or just do it yourself. 348, I'm going fast, not going back and checking my answers here. So if you find an error, let me know. Translate 4 less than twice a number. A number, that's my variable, we love x. 4 less than is minus 4. Okay, twice a number, it means you multiply by 2. If you have twice as much as me, you have 2 times what I have. So this is twice a number. 4 less than twice a number. Now we don't usually write in this order, so we rewrite it as this direction. Subtraction, oftentimes the words for subtraction makes it move back around. That's not an equation. You can't solve it. Okay, number 6. Solve this linear equation. Back in the day, you remember you want to multiply everything by something that gets rid of the fractions, probably, unless you love fractions. If you think about this as a common denominator, I can multiply everything by 8. So I have 24 over 8 plus 16 equals 24 over 4 minus 40. I picked 8 because 4 and 8 both go into 8. Now I can simplify. 3n plus 16 equals 6n minus 40. And then you solve from there. I'm not going to solve from there. You've done 8,000 of those this year. Solve and graph. Okay, this is a system, a single linear system here. We have and or. Okay, if there's an or, you shade everything and leave it all there. If it's and, you only keep the overlap. Or is everything and is overlap. Has to be both. So when I solve this inequality, I'm going to divide by -3. When you divide both sides by, when you divide by a negative with inequalities, it switches the inequality. So a is greater than -4. I don't look at the second equation. I just graph a is greater than -4. It's going that way. Everything bigger than -4. Go over here, solve, subtract 7. A is greater than or equal to 13. So I graph that one. 13, going that way. This was an OR equation. OR means everything. So I'm just going to shade in. So my final answer includes everything. So A is greater than -4 would be the final answer because the ORs overlapped. Again, if you're doing this on ISTEP, you got to drag the right little circles. It makes a difference. The sum of a number and a is at least -50. Okay. Is where my equal sign normally would be, but since it says at least, it's not saying is -50. It says is at least. That's an inequality. Okay, so I'm looking through here. The sum of a number and 8, I can put that in an 8. A number and sum means plus. At least -50. So I get this much of my structure together. Now I got to figure out what does at least mean. It means I could get -50, but I could get more than -50. So at least is -50 or more than that, greater than or equal to. Solve for A. This is the Pythagorean Theorem. It's kind of a weird one. A squared equals C squared minus B squared. You may have forgotten, solve for A by taking the square root. Square root of C squared minus B squared. That's Pythagorean Theorem in action. Okay, keep moving. I made video links for connections for all of these as well if you don't want to watch this video. Solve in an absolute value. You get the absolute value by itself. So we divide both sides by 2. And that leaves you with 3x minus 5 in absolute value equals 7. Absolute value means the positive sign and the negative sign, their distance from 0 is the same. So if I'm doing this problem, I need to have 3x minus 5 equal to 7 and 3x minus 5 equal to -7, or the opposite of 3x minus 5 equals 7. And I just solved both of those equations. Because if you remember, the absolute value of 4 is 4. And the absolute value of -4 is also 4. Okay, so I solved both of these. 3x equals 12, x equals 4, 3x equals -2, x equals -2/3. And you go back and check. You plug it in. 3 times 4 is 12. 12 minus 5 is 7. 2 times 7 is 14. That's the easy one to check. Plug in the -2/3. 3 times -2/3. You can do it on your calculator if you want. It's -2. -2 minus 5 is -7, but the absolute value of -7 is +7. So I'm good. This one says solve and graph. Again, same thing. You can't do anything until you get the absolute value to be by itself. So I'm going to divide both sides by 4. Kind of a little obscure example. So the absolute value is going to be bigger than 5. So I can solve this by saying x minus 2 is greater than 5. That's one of the solutions. So that's the easy one. X could be greater than 7 and it works because I want to end up with something bigger than 20. So that's this outside here. And then I got to think about, so the other end of absolute value, I want this to be x minus 2 is less than -5. Longer video on that if you want to watch it. But x is less than -3. So if you think about for a greater than absolute value, we're talking about something that makes it bigger on this end and bigger on this end. Doesn't matter because the negatives become positive anyway. If this would have been a less than, we would have been shading the part in between there. Okay, cross multiply and solve. Biggest mistake people make is not to do this. All of you can solve that equation. Some of you would write this. 4x plus 4 equals 14x minus 1. And none of you could all solve it and you wouldn't get the right answer. Don't be making stuff up. Stick to the rules of algebra.